In the shadowy corners of the scientific world, bizarre competitions unfold that challenge our understanding of what science can be. Welcome to a realm where the peculiar intersects with the profound, where the absurd reveals unexpected truths. I'm your guide today through this labyrinth of scientific eccentricity. Competitions, so strange they seem conjured from fever dreams, yet so brilliant they've pushed the boundaries of human knowledge. What drives brilliant minds to build machines of baffling complexity just to perform the simplest tasks? Why would prestigious universities celebrate research on the aerodynamics of flying frogs? The answers lie in the enigmatic territory we're about to explore. Science, at its most captivating, has always harbored a certain playfulness, a willingness to venture into the bizarre that often yields the most unexpected breakthroughs. Today, we'll traverse 5 territories of scientific oddity: the perplexing world of the Ig Nobel Prizes, where the seemingly ridiculous research reveals profound insights; the mesmerizing Rube Goldberg Machine Contests, where simplicity is sacrificed at the altar of complexity; science fairs that have transcended conventional boundaries, entering realms of delightful madness; robot competitions where mechanical gladiators battle for supremacy in arenas of wire and steel; and finally, the baffling Science Olympiads, where ordinary objects become instruments of extraordinary discovery. Each of these competitions exists in that tantalizing space between genius and absurdity, a space where true innovation often flourishes. Let us begin with perhaps the most enchanting celebration of scientific peculiarity: the Ig Nobel Prizes. Established in 1991, these awards honor achievements that first make people laugh and then make them think. Held annually at Harvard University, these ceremonies bring together Nobel laureates who bestow awards upon researchers whose work seems, at first glance, utterly frivolous. But beneath this veneer of frivolity lies genuine scientific inquiry that challenges our perceptions. Consider the 2013 Physics Prize, awarded to researchers who discovered that dung beetles, when lost, navigate by observing the Milky Way. What initially sounds like comedic fodder reveals profound questions about celestial navigation and insect cognition. These humble beetles, it seems, are amateur astronomers, charting their path through the cosmos with nothing more than their compound eyes and the light of distant stars. The tapestry of Ig Nobel-winning research is woven with threads of genuine brilliance. A team from the UK received the Peace Prize for demonstrating that swearing actually reduces pain, research that has implications for understanding how our brains process both language and discomfort. Another team won the Physics Prize for investigating why banana peels are slippery. Their research measured the friction coefficient between a shoe and a banana skin, revealing insights into tribology, the study of friction, that has applications in everything from industrial lubricants to artificial joints. Perhaps most mysterious was the 2019 Medicine Prize, awarded to scientists who measured the total volume of saliva produced daily by a typical 5-year-old child. Behind this seemingly absurd inquiry lay important questions about pediatric hydration and oral health. What makes the Ig Nobel Prizes so intriguing is not just their celebration of the bizarre, but their recognition that sometimes the path to profound knowledge wins through territories of apparent absurdity. Now, let us venture into the hypnotic world of Rube Goldberg Machine Contests, where participants construct devices of baffling complexity to perform the simplest of tasks. Named after the American cartoonist who illustrated comically complex machines, these competitions challenge teams to create contraptions that employ chain reactions to accomplish mundane tasks like popping a balloon or turning off an alarm clock, using as many steps as possible. The enchantment of these machines lies in their deliberate inefficiency. In a world obsessed with optimization, they stand as monuments to the beauty of complication. Each transfer of energy, from marbles rolling down tracks to dominoes falling to water-filling containers, is choreographed with mathematical precision, yet results in delightful unpredictability. The annual Rube Goldberg Machine Contest, hosted by Purdue University, has seen creations of staggering intricacy. One winning machine used 300 steps simply to squeeze orange juice. Another employed 215 movements to water a plant. The 2012 champion, a team from St. Olaf College, created a machine themed around the Toy Story movies that took 191 steps to inflate and pop a balloon, incorporating principles of gravity, fluid dynamics, electrical circuits, and mechanical energy transfer. What makes these contests so captivating is their perfect marriage of scientific principles with theatrical presentation. Teams employ pneumatics, hydraulics, thermodynamics, and electromagnetics, all to perform tasks that could be accomplished with a single motion. Yet in this seemingly futile complexity lies deep learning. Participants master physical principles not through textbooks, but through hands-on experimentation with failure as their most consistent teacher. They learn that the boundary between engineering and art is far more permeable than conventional education might suggest. Perhaps equally perplexing are science fairs gone wild, competitions that have evolved far beyond the baking soda volcanoes of yesterday into territories of genuine scientific oddity. Consider the International Science and Engineering Fair, where teenage minds have created projects of startling sophistication and peculiarity. One student developed a method to turn algae into biofuel using discarded coffee grounds. Another created artificial electronic skin capable of sensing pressure and temperature. But it's the more unusual entries that reveal the true spirit of these competitions. A student in Oregon investigated whether worms make decisions differently when listening to different genres of music. Another tested whether dogs have a preferred paw, similar to human-handedness. Some science fair projects venture into territories so strange they generate controversy. A 17-year-old once attempted to create a nuclear fusion reactor in his garage for a science fair and nearly succeeded. Another student tested the bacterial content of holy water from various churches, finding levels of contamination that raised eyebrows in religious communities. The Intel International Science and Engineering Fair once featured a project investigating whether people perform mathematical calculations differently when their bladders are full. Research that actually correlated with serious cognitive studies on how physiological states affect decision-making. What makes these competitions so valuable isn't just the projects themselves, but the freedom they give young minds to explore questions that established scientists might never think to ask. In the absence of preconceptions about what constitutes serious science, these young researchers often stumble upon genuinely novel approaches. Let us now enter the arena of extreme robot competitions, where machines battle in contests that blur the line between spectacle and serious engineering. Most captivating, perhaps, are combat robotics competitions like BattleBots and Robot Wars, where machines weighing up to 340 pounds clash in gladiatorial combat. These mechanical warriors, armed with spinning blades, pneumatic hammers, and hydraulic flippers, engage in battles that seem drawn from science fiction. Yet behind the spectacle lies serious engineering. Teams must solve complex problems in materials science, power management, and control systems. How do you create armor strong enough to withstand a spinning blade moving at 200 mph? How do you maximize the destructive potential of a pneumatic hammer while maintaining precision control? Beyond combat, robot competitions venture into even stranger territories. The DARPA Robotics Challenge tasks robots with responding to disaster scenarios, climbing ladders, driving vehicles, and traversing rubble-strewn environments. The sight of humanoid robots attempting these tasks, falling in surprisingly human ways when they fail, is both uncanny and mesmerizing. Underwater robot competitions challenge machines to navigate complex submerged obstacle courses or collect specific objects, tasks complicated by the challenges of waterproofing electronics and managing buoyancy. Perhaps most perplexing are microbotic competitions, where robots smaller than a grain of rice compete in feats of navigation and manipulation. These tiny machines, often visible only under microscopes, represent the frontier of miniaturization technology. What unites these competitions is how they drive innovation through structured challenge. By creating specific, often bizarre scenarios, they push engineers to solve problems they might never encounter in conventional research. Our final destination is perhaps the most baffling: odd and unusual Science Olympiads, where conventional academic competitions take strange and wonderful detours. The Science Olympiad itself features events of surprising peculiarity. In Boomover, students build structures from balsa wood that must support as much weight as possible while weighing almost nothing themselves. Mission Possible challenges participants to create Rube Goldberg machines that must accomplish specific tasks within strict parameters. Then there's the egg drop competition, where protective containers must be designed to prevent an egg from breaking when dropped from increasingly dizzying heights. While seemingly simple, this challenge incorporates principles of materials science, physics, and engineering in ways that generate surprisingly sophisticated solutions. Beyond conventional science, Olympiads lie competitions of even greater strangeness. The toilet paper physics competition challenges participants to perform legitimate physics experiments using only toilet paper and minimal additional materials. The International Rock Paper Scissors Championships have been studied by mathematicians and game theorists to understand probability, psychology, and decision-making under pressure. The competitive mathematics competitions challenge participants to solve problems so abstract and complex they seem to exist in alternate dimensions of mathematical reality. What makes these competitions so enchanting is their ability to transform the ordinary into the extraordinary, to reveal the complex scientific principles hiding within everyday objects and actions. As we conclude our journey through these bizarre scientific competitions, consider how they remind us that the scientific spirit thrives not just in laboratories and academic journals, but in playgrounds of creativity, where the boundaries between disciplines dissolve and the rules of conventional thinking are suspended. Perhaps the most profound scientific discoveries await not in the expected places, but in these mysterious borderlands where brilliance and absurdity dance together in perfect, perplexing harmony. Closing animation with credits and suggested further viewing.